So, hi everyone. So, you're welcome. Let me know if you can hear me. Hope you can hear me. Just drop a message in the chat if you can get me. I'll just give a couple of minutes, maybe 1 or 2 minutes for everyone to join, those who want to join, and then we are going to start. So, I hope everybody can hear me and you're all welcome. So, I want to talk about serverless and machine learning today, as machine learning is part of AI. So, some of you want to get started, just have a brief discussion so that you can get started on serverless and machine learning on AWS. Okay, so can anyone hear me? So I'll just give, let's say, 2 more minutes for others to join, and then we are going to kick in with our discussion for today. Okay, so yeah, 2 more minutes is gone, and now we can start. So first of all, I am Cyril Bandolo. So I am an AWS machine learning hero. I've been a hero for the past 2.5 years now as an AWS machine learning hero. So I started from the analytics side of things, the Excel, SQL, learning R, and then Python. So I'm from the analytics part of things. And then I've been evolving as things have been evolving. Back then, R was more prominent than Python. But later on, when we had packages like TensorFlow, PyTorch, Python took over R, and then you had data science coming at the forefront, machine learning, and now everybody's talking about Gen AI. So I started learning the cloud, AWS specifically. That's why I'm an AWS machine learning hero. But then I also got to work as a developer for Serverless Guru, and primarily Serverless Guru is focused on serverless clients. So doing lots of serverless development work. So I understand the analytics part of things and the machine learning. Then I also have worked with serverless developers, understanding the, how can I say, the best of both worlds. Also, with my quest for learning how to share knowledge, I became an AWS authorized instructor. So I went through all the rigorous procedure to be recognized as an AWS instructor so that I can be able to deliver, share, spread knowledge maybe better after learning from the experts, especially the soft skills when you are sharing. So let's dive straight on with what we have for today. So the first thing on our agenda is what is serverless. So we are going to talk about what serverless is all about and yeah, what is not. We are also going to look at what machine learning is. Thirdly, we are going to look at what serverless machine learning is, which is an interesting combination between machine learning and serverless. So we are going to look at what serverless machine learning is. And then I'm also going to show you three parts to serverless machine learning, which would get you started based on the workload you have. Each one has its pros and cons. Then I'm also going to give my advice to you on how to get started. So if we have a couple of questions, we can also do the Q&A. So the first thing is that let's look at what serverless is, and then we'll be able to understand what serverless machine learning is. So if you look at this image here, you'll notice that when you're using infrastructure services, you do most of the work. So AWS is only in charge of the compute and storage, the hardware. The rest of the code and the data, you have to provide that. Client-side encryption, OS configuration, network protection, server-side encryption, platform management. So you have a lot to do when you are using infrastructure services, while AWS just provides the hardware, the compute, then most of it is carried by your developers' shoulders in your company or your structure, or if you are the developer. But on the other hand, when you go serverless, or when we talk about your running your application with a serverless architecture, you see the things are flipped. On the left side, you have more responsibility, while when you go to serverless services, you have less responsibility, while AWS takes on the bulk of the responsibility. So all you have to do is look at your code, make sure your code is okay, your business logic is okay, provide your data, maybe your company data, do some client-side encryption. Then the rest is handled by the cloud, AWS in this case, your operating system configuration, network protection, server-side encryption, platform management, all of that now is handled by the cloud. So you have less to do, you have more time to be creative. So that is moving from infrastructure services architecture to a serverless service architecture. The key thing is you push most of the, I can say the not so interesting work to AWS, and then you are left with just the core and a few things to work on yourself. Now, for those of you who are looking at serverless coming in for the first time, the major thing about serverless is at the heart of it, there is this service called Lambda, which is a service that you can't do serverless without using Lambda. It's at the heart of serverless, and it's a fully managed service by AWS. So it is actually serverless and serverless itself, because all you need to do is just write some code, and Lambda is going to do the rest of the work for you, push things around, because it is also event driven. It's an event driven service, which means that it's using, it's like there should be an activity, there's supposed to be an action, and it's going to trigger your Lambda to react. So it's very good when you have traffic coming to your application, maybe unpredictable traffic. Is going to trigger a Lambda, and Lambda is going to react. And then when there is no traffic coming, Lambda does nothing. And that is why you pay as you go, because you only pay for the service you use, because it only gets triggered when there is an action. So you pay just for when there is an action or an activity, which means it can be favorable for maybe a small company or somebody who wants to start up something, just knowing that I don't need to spend a lot if I don't get much traffic. But as soon as I get much traffic, okay, I can invest more in that service. So if you move from maybe 2 people visiting your website to 1 million people visiting your website, you see that yes, you can share that revenue with the cloud happily, rather than having a flat rate and you don't know if you get 2 users or maybe 1 million users. So another thing is that AWS Lambda integrates very well with other services. So other services I mean, I doubt if there is any service in AWS which really doesn't integrate well with AWS Lambda, because AWS Lambda is at the core of serverless, and it really integrates. I mean, you're able to use it to link to so many services at the same time. And another interesting thing about AWS Lambda is that it supports many languages. So if you're comfortable with Python, or you're comfortable with Node.js or TypeScript or Go, it is able to support many languages. So you don't need to move away from your comfort zone and try to learn a new language. Your programming language that you're comfortable with, AWS Lambda is going to take it and do the job for you. Now, what have I noticed while working with serverless developers on the same team, given that I'm from an analytics background mostly? Their strength, their comfort zone, where they shine the most is on web development. So these are typically people who wanted to build websites. So they decided to learn HTML, CSS, JavaScript to be able to build applications front end. They're mostly full stack developers who build front end and back end for an application. And they expect that, okay, a user just needs to come to my interface through a front end, send a request, and then everything is going to go through the back end, and then I'll send back a response. So most of the time, I have noticed that they are comfortable with Node.js, TypeScript, and very few. I mean, I would say I've spoken with lots of really hardcore serverless developers who are coming from the web development background most of the time. They are not versed with Python. They are on the Node.js and TypeScript, because that is easier to do your front end, your back end, your full stack. That is easier to do with TypeScript, Node.js. So that's why they stay there. And then they are used to using infrastructure as code, because that helps to build the infrastructure. There are so many moving parts, there are so many assets, there are so many things to build in a website. So the serverless developers learn how to use infrastructure as code, which is very important to push their application to the cloud, for example. Then services like AWS Lambda, which I've mentioned earlier, is something that they use on AWS a lot. DynamoDB for the NoSQL storage, because it's very fast and can scale very well. Also, API gateway and app sync are used like your door, your gateway, between the clients and touching your back-end services. So they are what would authenticate or would link what the front end is requesting to what the back end has to provide. So these are services that these serverless developers are more comfortable with when I work with them. And on the flip side, they are not too comfortable with calculus. So that's why, for example, when I talk to a couple of serverless developers about machine learning, they would say, no, 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 there's too much calculus in it. There's too much mathematics and statistics, linear regression, and all that. I don't want to get into all of that. I'm comfortable with just using my HTML, CSS because too much maths and calculus is I mean, is something I'm trying to avoid. So that is also the more reason why maybe they don't want to consider machine learning. And then another thing too is they usually have a limited machine learning algorithm knowledge. So every time there is a new Gen AI model that is out here, it gets confusing. And if you maybe you don't have the roots, you don't really have the base, you don't understand where it's coming from and where it's getting to, you might be overwhelmed. And at times you might just even feel that the whole ML algorithm thing, machine learning or Gen AI is like magic also. So it becomes it's kind of confusing for those who are not from the machine learning background or mostly serverless developers. And then, as I said, their knowledge in Python for data science is really non-existent because all of us learn core Python, and then from core Python you might learn classes. Now people start branching out. The serverless developers would want to learn more of Flask or Django and move on to build websites, while the data scientists, after learning the core Python and classes, they'll want to move now to packages specific for data science like Pandas, NumPy, Seaborn, Matplotlib. And these are the packages that are more linked now to the data science work that they have to do. Scikit-learn, and PyTorch, TensorFlow, I mean, things like that. So the paths deviate. And that is also the more reason why the serverless developers have a weakness when it comes to Python for data science. Now, we've talked about serverless. Now, let's talk about machine learning, and then we'll be able to understand how to bring the two together. So, machine learning comes to solve a problem that traditional programming has had for some time. So, starting with traditional programming, traditionally, when you want to build an application or you want to do programming traditionally, you would typically bring in your maybe your data, company data. You bring in your data, you would write the rules, send it to the machine, and the machine is going to be providing you with answers. So let's say you program the rules, let's just say for an interest rate or a bank interest rate, for example, if the income or the bank balance is between 0 to 10,000, apply 5% interest rate. If it's between 10,000 to 20,000, apply 10% interest rate. If it's between 10,000 to 30, apply 30% interest rate. So it's just something that you'll be programming the rules all the time and providing the data to the machine. Then the machine will be giving you answers. Now, when it comes to machine learning, it's kind of different. Imagine you have to identify somebody's face, you want to identify, okay, this is this person's face. How would you program it if the nose is round, or it gets confusing? Let's just say you have something like apple. You want to program how to identify an apple. You would say it should be soft, it should be round, it should be red, if round, if soft. But a tomato could be all of that. So it becomes a bit complicated to use traditional programming for some kinds of use cases. So that is why machine learning comes instead with okay, I'm going to provide you data such as like cats, for example. I'm going to give you the images of all cats. Okay, this is a cat, this is a cat, this is a dog, this is a dog, this is a cat, this is a cat. Maybe 10,000 images of cats, 10,000 images of dogs. And then now, when I give it to the machine is going to find the rule itself and say, okay, based on what I have seen, based on the fact that I've been seeing so many cats and so many dogs, I now know that cat looks like this with whiskers, or even let's talk about the smile, for example. Based on the images I've seen and all the pictures I've seen about smiling, I know that for me to identify somebody's face, I'll look at the smile, I'll look at maybe the eyes, and then I'll be able to know this is this person. Or so it's going to find its own rules, and then it's those rules that were difficult for you to program in the traditional programming, and you take those rules now and apply now to future situation or to a future context. So you're actually letting the machine find the rules for you, give you the rules, and you carry that rules along everywhere you go. That's actually what you're doing. So now let us understand where machine learning suits fits in, because we are talking about machine learning, we're talking about AI, we're talking about so many terms, Gen AI. It's good to clear that. Let's talk about the elephant in the room, because there are so many general models that we see every day now coming out, and we are like, it feels like the only thing happening now in the world is Gen AI. In reality, AI is is the umbrella when you want artificial intelligence, that you want the machine to do something that traditionally we know these things are done by humans. So we want to train the machine to do something that, yeah, it's not normally doing, right? So you can either use machine learning, or there are other methods that are non-machine learning models. So the key thing about machine learning is that machine learning uses statistics, uses past data, uses that statistics to be able to come up with its answers, you know. But the non-machine learning part of AI, like robotics, don't necessarily use statistics. You could build something to just maybe an arm just to open and close the door every 2 seconds. So there's no major statistical analysis that is going on for it to do that work. So that would be non-machine learning AI part of it, you know, still under AI, but the non-machine learning part of AI. But the machine learning part of AI deals with using statistics, linear regression, and things like that. Now, under machine learning, now you can have deep learning models or other machine learning models that are not deep learning. So deep learning is just that machine learning wanted to take the step further by trying to mimic the human brain, the neurons that we have in our brain. We have so many neurons. So you can think of it like maybe a baby trying to see shapes first, see colors, then later the shapes and the colors identify the person. So in different layers in the deep learning network, the neural network would be trained to identify different parts or different things, which when they come up together, they'll give that prediction that you're looking for. So there are other machine learning models that are not necessarily deep learning models, like linear regression, support vector machines, so many logistic regression, so many other things that you can do, which are not necessarily deep learning, but they have their own use cases, especially for tabular data, right? So the deep learning now can be split to Gen AI or other deep learning models that are not Gen AI. What's the peculiarity of Gen AI? The peculiarity of Gen AI is that Gen AI focuses on creating new content. So it's trying to create a content that looks like an original content that has been seen before. So it's trying to create something that I'll be convinced that yes, this looks like something I've seen, or this looks like a song that I mean, this looks like how we play this kind of brand of music. So it's like listening to so many brands of songs, and then it says, okay, I can also create those kind of songs myself. So it's trying to give you and like kind of like an original, make something look like this is how the original of this thing is usually done. This is how it's usually done by most people. That's the peculiarity that Gen AI brings. But then there are other non-Gen AI deep learning models like convolutional neural networks, recurrent neural networks. They also do other things, but they are not necessarily trying to create a copy that looks like the original. Then in Gen AI, again, we are talking about LLMs. LLMs, it feels like the whole world revolves only around LLMs, but it's not only LLMs that we have. We also have GANs, because LLMs is more of, okay, what the speaking. I mean, the how do we converse? How do we speak? What is our way of like writing? It's more on the text part of things, while you also have the vision, the view, like the self-driving cars. I see an obstacle, I see an object, I see maybe somebody crossing the road, or I see I mean, your face detection. This is this person. I can grant access to this person to this hall. You know, things that come up there like deep fake. So that there's also the part of Gen AI which deals with videos, which is also used for certain use cases. So here we would hear mostly about LLMs nowadays, but I just want us to know that it's not only about LLMs today. There are so many other things going on besides LLMs. Now let's look at the typical person doing machine learning or data science on AWS. The core service which you would be spending most of your time on is SageMaker. So SageMaker is the machine learning Swiss knife. It can be used for so many different things that you want to do on AWS as concerns machine learning. So SageMaker would is an AWS managed service, and it would help you create models. It can train models for you, deploy models that you've already created, and it has pre-trained models as well, built-in models, and you can even manage your instances yourself. So SageMaker has so many interesting things that can be used when you are doing machine learning, as well as it integrates with other services. So SageMaker integrates well with other AWS services. And as a machine learning engineer, you would notice that SageMaker would be the major service that you will be using to be able to get your work done very, very easily on AWS. Now that we know that, okay, SageMaker is the core for machine learning engineers, Lambda is the major service that you need to know when you're doing serverless. But then what also are the strengths? What is the comfort zone for machine learning engineers? So most of the time, the machine learning engineers and the data scientists, they come from analytics background, just like I explained earlier. I come from analytics background. So most of the time, they come from this data-driven analytics background, and then they are more comfortable with Python, as Python has lots of interesting packages that help you with data preparation, cleaning, and all those things. So they are more comfortable with Python. Also, they use TensorFlow and PyTorch, because these are very interesting packages that changed the landscape a couple of years back when they were open sourced by LinkedIn and Facebook. It made Python to become really very popular, say compared to R, which had very good statistical analytics. I mean, it was very good with statistical analysis, but Python, because of packages like TensorFlow and PyTorch and other subsequent packages that were created and put in Python, it made Python to beat the R hands down, you know. So SageMaker is also a service that machine learning engineers are very comfortable with, because, as I said, it's a Swiss knife. in AWS. You just need to learn it if you want to do machine learning on AWS. But now, what is the weakness of a typical machine learning engineer? You can see that it's like kind of the opposite of what the serverless developers have like weakness. I mean, their strength become the weakness here, the weakness becomes the strength there, and you'll see where we are heading to. So machine learning engineers, they are like saying, okay, I think HTML and CSS is boring. I don't want to be defining borders, defining how I'm going to path, defining if it's going to be responsive or not. So they say, okay, I'm not interested in learning HTML and CSS. I just want to run my code, train my model, let it be more accurate, let's be able to predict something and be able, I can give it pictures of cats and dogs. It's going to tell me this is a cat, this is a dog. I can be able to predict the churn rate in a bank, for example, or default rate for loans. So they have a different focus, and that is why they are avoiding HTML and CSS. And also they are more focused on how can I make my model more accurate. I want to launch a new Gen AI model that would have less hallucination, that would be maybe more accurate, predict better. And also they are not that their strength is not there with DevOps. That's why things like MLOps are insisting for people to learn, especially machine learning engineers and data scientists, because DevOps will help for CI/CD to be able to seamlessly deploy your code. But because machine learning engineers, most of the time, their strength is the accuracy, the analytics, those packages, building those, creating those models, then they are not really that good in the whole CI/CD thing. And also there is less software engineering principles, because like, okay, we are just going to make sure the model works, and then the other developers would come in and take it and add it to production or add it to the pipeline. So there is not too much focus on the software engineering principles for the tradition, for the normal machine learning engineer. But now let's look now at what serverless machine learning is all about. And I'm sure you might already be guessing, because traditionally we've talked about serverless here. So we've seen that with serverless, you look at the code and the data, and then your client-side encryption. The rest of the activities, you push them to the cloud to do. That is what serverless is all about, like we defined earlier in this our talk. Now, serverless machine learning, you're just slotting in the machine learning code in that serverless architecture that you already have. So you can see that, yes, AWS still takes care of the bulk of the work, but the difference here is that your code now includes ML code, and your data, maybe some data which can go with the ML code, and the rest is you're just trying to maintain that serverless architecture where you do less and the cloud takes care of most of the work. Your code and data, client-side encryption is you, the rest you push to the cloud. So that is serverless machine learning, where you are benefiting from the best of both worlds, the serverless and the machine learning world. So why would developers love serverless machine learning when they have the opportunity? Because clearly it's not every opportunity that you would want to build with serverless machine learning. Not every application needs serverless machine learning. But then when there is an opportunity to use serverless machine learning, why do developers love it? The first thing is that it helps them to build more innovative and modern apps. So the serverless developer will be, okay, now I can add some smarts to my app because I'm now bringing in machine learning to my serverless architecture. So I'll be more innovative. and then I'm going to have more modern apps, because the customer expectation right now is so high. And if you have an application that is not really having some smarts in it, you build an application and it doesn't have like recommendation system, it's not really smart, you try to search for things and it's not supporting you in the search, it's so rigid. There are some things that are already by default customers expect from every application. So now when you add machine learning to your serverless, that's serverless machine learning, you now have more room for competing with what customers are already accustomed to daily. Also, when you use a serverless machine learning way of building, you don't need all that maths to get started. So you don't need to go into serious calculus, go so deep. You just need some understanding of a couple of things, but then you don't go that deep, because now you're coming from an angle of a serverless machine learning um, way of building things, which I'll show you as we are talking about the paths to serverless machine learning. Now, you also leverage the cloud service integrations. So now you're in the cloud, you're going to benefit from the fact that you can jump from your Lambda, link it to maybe your SageMaker. SageMaker can talk with other services like CloudWatch and EventBridge, AppSync, API Gateway, and also you're like connecting with other things, database services, Aurora, or you're even using QuickSight. So this is, you're able to integrate with other cloud services very easily when you go the serverless machine learning way of building things. And all of this is just to improve developer velocity so that you can be able to build faster and also be more efficient in building your application. Now, looking at a traditional machine learning engineer, why would serverless machine learning be interesting if given the opportunity to do some serverless machine learning instead of just building the application in a traditional machine learning way, maybe with a real-time endpoint, for example? The first thing is that there is no need to provision servers. Provisioning servers, trying to manage the traffic when you launch, deploy your model. You don't want to manage how the model is going to scale. You want to manage the concurrency, so many things. You don't want to manage that. So you don't even want to bother about the servers. That is why the traditional machine learning engineer would love serverless machine learning, because it's just going to fit into that serverless way where most of the servers, in fact, the servers management is pushed to the cloud, and you just focus on your machine learning code. So no need to provision servers. Also, there is more app integration. You can now integrate easily with other parts of the application, because you now can have an end-to-end application to present to someone. Say, okay, here's my application and this is how it works. It's not just my model, and then you're trying to say, okay, put in the data in a JSON format and send it to Postman or someplace and see how it works. But then you have a full application, because you're now just joining the trend of building the full application, but now including your machine learning code inside. So you can deliver an endpoint to someone, and the person fully tests your machine learning powered application end to end and say, okay, this looks good. I love it. Then you also have cost optimization, because now you're no longer having maybe an always on server for unpredictable demands. You now pay per use, pay as you go. You've moved from just provisioning a server and paying a flat rate whether there's traffic or not. Now you pay as you go. It means there's that cost optimization And if you're like a company that wants to test, build an MVP, want to try something, you love this. It's going to help you optimize your cost when you go your serverless machine learning. And also there's more team collaboration, because most of the time in a serverless machine learning environment, you'll be building in a microservice environment. So you need to collaborate with other teams while you bring the back end machine learning part of it. There will be front end engineers, front end developers who will need to collaborate with you and build that microservice, that application that is built by different people with different strengths, and can scale. Each of the microservice can scale differently. Again, developer velocity, so it makes things go faster. We have more time for creativity because all the server provisioning and app integration is now seamless. We can now think of how to just make things more interesting and also build faster. So now that we've seen what serverless is, what machine learning is, and then we've also looked at serverless machine learning, which is like the best of both. Now let us look at how to get started with serverless machine learning on AWS. And there are these three parts that we'll look at. The first part is using AI services. So if you have an application, let's say you have an existing application, and in that existing application, you don't like have machine learning in it, and you're interested in putting in machine learning, but you don't have machine learning experience, then the best way to get your foot in is to use AWS AI services. So this is ready-made intelligence, which can easily integrate with your application very easily, because they are just API calls that you're doing, and then they continuously learn from your data, learn and improve. So they are doing the work for you. As I said, you don't need any machine learning experience because you are just calling APIs like Amazon recognition for face recognition. All you need to do is just call that API, add it to your current application. Let's say you have an application that you built maybe some time ago. You just want to make it more innovative. You call Amazon recognition and you would have face recognition. You can call Amazon transcribe for speech to text. So it's going to transcribe the speech to text, and maybe that's what your application is supposed to do as part of its services that it offers or its functionalities. And also, you have AI services like comprehend, personalize. There are so many AI services that you can use based on your use case. And this is the easiest because you just call an API. You don't even know what is going on under the hood. You don't need machine learning experience, and everything just works for you. The second way you can get started with serverless machine learning on AWS is with your SageMaker serverless inference. So SageMaker has a couple of endpoints that you can use to deploy your application. But when you use SageMaker serverless inference, it's just like using a Lambda in front of your other SageMaker endpoint. So the Lambda is already integrated in the endpoint. So it scales when there is no traffic. It's event driven. When there's no traffic, then your endpoint goes down. When there is traffic, it starts the Lambda and your endpoint is going to provide inference. So as you can see, most of what you can do serverless machine learning on AWS is inference, because it's so complicated to train, billions of parameters. It's so complicated, and at times you have these resource limitations. Lambda can time out after 15 minutes. So that's why you're like, okay, I'm doing serverless machine learning, but most of it is how can I do my inference serverlessly? Given that you might train just once, store the model, and the rest of the work is just the model inferencing, because like we said, machine learning, the rules, you found the rule already, and then each time it's just applying the rule to each new situation. So you don't need to retrain it again. You don't need to create new rules. You've already found the rules, save the rules, and all you need to do is inference, 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 inference. So there is no need to manage your servers because of this SageMaker serverless inference. And then it integrates also easily with MLOps, machine learning operations, which is a mix of DevOps, machine learning, data engineering. So it integrates with your MLOps pipeline so that you have an end-to-end deployment. You automatically control, automatically integrate all your deployment and development so that you just seamlessly make changes to your application and everything goes to production without breaking down, without anything breaking. So you can easily host your models in the SageMaker registry. Those are the advantages of using the SageMaker serverless inference. So in this situation, you have a bit of machine learning knowledge. You can use the inbuilt models in SageMaker, such as linear learner. You can use the inbuilt models there, and then you want now to create an endpoint that is real time. No, sorry, an endpoint that is serverless, not real time. Real time would cost you more, it's always on, but an endpoint that is serverless that goes on and off based on the traffic. So you only pay for what you use. This is where you can use your SageMaker serverless inference. You see that you have fluctuating traffic, it scales down to 0, and also you pay per use, like we've said. And you can also use provision concurrency. The third way of going serverless machine learning on AWS, given that you have, say, your own model, you want to build your own model, or let's just say you have an ensemble, let's say you have like 5 voting models that are supposed to vote, say, okay, if 4 out of 5 of these models say that this picture is a cat, then it's actually a cat, or 3 out of 5. So that model doesn't really exist. You have to build it yourself. So as you see where it's driving to more customization here, you have good machine learning developers on your team. They've created their own model or something really interesting. It's not available on AWS. You now put it in a container and you push to AWS using the Lambda container image. So you're going to deploy your Lambda function as container images. You store it in ECR, Elastic Compute Registry. So you're going to store it there, and then you have the limit of like 10 gigabyte memory. That is the downside, because transformers, for example, cannot fit here. Again, that's what we are saying, that you only use serverless machine learning when it's usable, when you can, but there are situations where you will not be able to use serverless machine learning. But if you see that you can use serverless machine learning, maybe because your model is light, is below 10 gigabyte, then it'll be interesting for you based on all the benefits we've seen before, no provisioning servers, developer velocity, and all that. So we have that limit of 10 gigabyte memory, so it has to fit in there. So you can use any programming languages you want, Python, Node.js, Java, whatever. You build it, you put it in your container Docker, and you push to ECR. So you just need to package all your libraries and the model weights. You package all of them and put them in that container as you're deploying to ECR. So light models like Pandas, Scikit-learn, PyTorch can be used here very effectively. So if you feel or you test and you see that any of these models can go with the issue or the application you're trying to build, then why not? You can use your Lambda container image, given that they are light and they'll most likely not be more than 10 gigabyte of memory. And also, it helps you with easy model versioning with your container tags. So container tags, you're able to know which version of the model was very effective, which version of the model was not that very effective. So it's a good thing if you have your own model, you want to bring your own model to the cloud and store it as a container and serve the clients serverlessly, serverlessly without using any of the current models that AWS already has. So these are the three ways of getting started with serverless and AI or machine learning on AWS serverless machine learning for those of you who are interested to start. So my advice, the first one is to always think in terms of microservices, because when you think in terms of microservices, you'll be able to focus on the different parts. On the one part, there's the machine learning model, which is doing its job and it's mostly using Python. Then you expose an endpoint. Then on the other part, maybe there's the front end, which is using React, TypeScript. Then it's going to connect to that your back end. So when you think in terms of microservices, it makes it easier because each of the microservices can scale independently and you will not need to modify all the entire application every time. Insofar as you have parameters that are being exchanged between the different microservices, there is basically no problem. So that is a better way to go about your serverless machine learning, by thinking in terms of microservices. How can I build this microservice, exchange this parameter to this other microservice, and together when they come up, we have the full application. The monolithic would be complicated because you'd have to do lots of things, and changing one thing you need to change almost everywhere. Whereas microservice, you just need to focus on each part, optimize it to its best, and it's going to support the other parts. Second advice, like Werner always says, reinvent is around the corner. We know reinvent is next week. Go build. We can't do any of this without actually building, because it's in building that you actually learn. It's applying your knowledge to build something that people can use. And when you build that, you learn, and at the same time, you're able to showcase what you've learned. So you just need to find resources and find ways to build and get started with serverless machine learning on AWS, given that you've understood the three methods: AI services, SageMaker serverless inference, or using Docker and ECR if you're more comfortable and want to bring your own machine learning model to the cloud. Again, there are situations where you can't use any of these serverless machine learning way of doing things because for some reason maybe your model is too big, or your training, and there are so many parameters you don't want to your model goes above the 15 minutes of lambda, and it's very difficult to keep the state because lambda is stateless. You also have models that are above 10 gigabytes, so it's complicated to fit it in a lambda container image. Definitely you wouldn't use serverless machine learning in these situations. In case you want a practical guide to learn, so I'm just going to insert the slides of my course in case you want to have the practical guide. So I recently launched the course and I'm building it along, and it's going to go on along right up till early next year. We'll be building together, so I'll be available for feedback for anything, and all the projects we'll be building. So we launched the first project. So it's a serverless machine learning course. I'm building it with Serverless Guru. So Serverless Guru again is where I work. So it's a course hosted by Serverless Guru, and the person building the course. So you're going to learn hands-on to build with these services that you see here, like AWS Lambda. We're going to be building lots of applications with AWS Lambda. Remember, AWS Lambda is at the core of serverless, so there won't be any project you build without using Lambda. You'll be using DynamoDB for storage, using API Gateway, Event Bridge to better coordinate between the microservices, as we said. And then you have SageMaker, which is the Swiss knife for machine learning engineers. You would also use serverless framework for your infrastructure as code, AWS SAM as well, Docker, And remember the Docker and ECR to bring your own model to the cloud just for testing, or to test your application, because you need to test them, integration testing, unit testing, end-to-end testing. All of these will be touched. And also GitHub Actions, so that you can use a smooth CI/CD and push your code directly to AWS. So these are the things you touch in this course. And if you see here the projects, you build a serverless e-commerce application without AI. So that is like learning, okay, this is how serverless is done without AI, just pure serverless. Now I understand what serverless developers do. Next, serverless machine learning e-commerce app with AI service added. Okay, I have this, my serverless app. I want to add an AI service to it. How do I add it? You're going to see how to add it. You're also going to build a SageMaker application without serverless. So my application doesn't need serverless machine learning or serverless. It's just a pure machine learning application. This is how it's going to be built. Next, now, okay, I can use serverless machine learning in this my machine learning application. So serverless machine learning SageMaker application, now using the serverless inference that we just mentioned here and all these benefits, you're going to build with it as well. And then you're also going to use your Docker and ECR to build your serverless machine learning app and bring your own model to the cloud. So all this is just to equip you with these tools and the flexibility to get you started. So on the right, that's the QR code. The course is already launched, so you can already go there, grab it, and start learning. And project one is already there. The other projects as well are already being added. Just check in, and all your feedback would be used to improve the experience you're going to get as we learn together and build towards the future, because you know this is hot now, serverless and machine learning, and we are trying to bring these together in serverless machine learning. So thank you. I'm hoping you can always get in touch with me through LinkedIn, through Twitter, and even on Blue Sky. So we can have a chat at any time, so I can help you out to get you started with serverless and AI on AWS, especially as we move towards the end of the year and start next year with so much energy. So thanks everyone for watching. See you next video.